Hi everyone, this is Aruna Arichami, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series, today we're going to see about the transaction concept in database management system. Under the transaction, we're going to discuss about the schedule. So what do you mean by schedule is nothing but it is a piece of instruction or sequence of instruction. That particular instruction can be executed in any order. Either it could be a psychological or chronological. The particular transaction can be executed. In that particular execution, you're having more than one transaction. That is, each transaction can be executed in a concurrent manner. So out of this thing, we can able to see that a schedule can have the multiple transaction. Each transaction can be executed in a certain order and it could be executed in a concurrent manner. This is the definition of a schedule. While executing the schedule, you can come across the two cases. One is successfully completed, another one is failed to complete. When it could be successfully completed means once a commit statement can be executed by the particular transaction, we can say it is a successfully completed. Or otherwise, if it is intermediately you are having any failure, automatically your transaction can execute the abort or a rollback statement. Through that, the particular transaction can be failed and send a notification message to the user. Automatically the page can be moved from you to your home pages. So the example for the schedule 1. So where this type of a schedule can be used means in real world entity or OLTP we are using this one. So GPay, net banking or in any e-commerce application, if you are transferring any amount, definitely we can able to use this type of a schedule. Under the schedule, it can be classified into two types. One is a serial schedule, another one is a non-serial schedule. The example for a serial schedule is this one. Here T1 can transfer the amount of 50 or $50 from account A to the account B. In this case, after completing the transaction 1, that is after executing the commit statement only, it will leave the resource to the another transaction. In my transaction 1, just amount is debited from my account A, it will be credited to the account B. In my transaction 2, whatever the balance amount available in my network, in this thing 10% of amount can be transferred from account A to account B. So this is in this thing a schedule can be executed in T1 to be followed by T2. So in real world example also, this is the payment successful. That is, the payment can be successfully credited from account A to account B. In real world, all the OLTP processing we are using this type of a schedule only. In second cases, this is the T2 to be followed by T1. This is not an exact schedule of T1. Something is executed under the T2. After committing the thing, it could be followed by T1. This is also best example for the serial schedule. In real world, either we can use schedule 1 or a schedule 2. These are the both example for the serial schedule. Second thing is the non-serial schedule. In this case, your transaction 1 is partially executed. It will leave the resource for the another transaction. This type of a schedule we can call it as a partial execution of an instruction. That is a partial schedule. If it is a partial, it could be committed. So it is a payment is successful. And also it could be called it as a not a serial schedule or a non-serial schedule. In this thing, this particular schedule is very much equivalent to schedule 1. What could be the output of schedule 1? The same as over here. But here, it will first execute the read statement of the first account. That is that debitor the $50 from that particular account. It can be updated. It will leave the resource for transaction 2. Transaction 2, what it could be done? The amount A, the balance amount of 10% can be debited over here. Again, it will leave the resource for B. Here B, it can be credited that 50 from the which could be debited from the account A, that could be credited over here. It will execute the commit statement over here. What could be in our transaction 2? After completing this, it will leave the resources over here. Here also the particular temporary amount what could be debited over here, that could be credited over here. It is also executed the commit statement. Here this particular instruction, this thing can be executed, fully completed. So this is can be equivalent to schedule 1, and also it is not a serial schedule, just it is equivalent to a serial schedule. So schedule 4 is never used in our real time thing. Why it is never used means it will never preserve the value of A and B. That is, the original data is not preserved over here. So only we can call it is the inconsistent. See here in the first transaction, A can debit a certain amount. It will not update it. Again, it will leave the resource for transaction 2. In the transaction 2, 10% of balance amount is debited and it will update it over here. It will read the bid account. Next, come over here. It will leave the resource for transaction 1. In this case, A value can be updated by the T2. It is not a original value what could be read it in the previously. So here data can be changed. So only we can call this is the inconsistent. Never using in our OLTP applications. Because it is inconsistent, it never keep the original value over here. So in my next lecture series, we are going to see about the serializability, different types of a scheduling technique. Thank you for watching my video.